Go ahead and get started. So it's already time for the last session of the conference, last but not least. So we're going to be talking about start-to-end fair analyses, and all of these talks are going to have a bit of a neuroscience flair to them. And first speaker, we're going to welcome JB Poline. So JB is going to talk about distributed data, standards, governance, and analyses in the neurosciences. And JB is a professor in the Department of Neurology and Neurosurgery in the School of Computer Science at McGill. He's also the director of the Origami Neuro Data Science Lab, PI of the Neurobagel and Nipoppy projects, chair of the International Neuroinformatics Coordinating Facility.
Not anymore. But
yeah, okay. There's really a lot more here.
It's
so
super hard to keep up with it. And the things there are a couple of things I resigned from, and a couple of things I was. Anyways.
All right, JB.
Yeah, it's not going to be as technical and interesting maybe for a bunch of you, but I would like to describe a little bit of an experience on the distributed aspect of data sharing. And so I'll do a slightly different thing that I usually do. So I'll try to do a little bit of why, why I think that distributed aspect in neuroscience and in neuroimaging is kind of critical now. It has already been, but even more now. And then the what, the how, and the conclusion. And the how is probably the most interesting aspect. So the why is, I don't know if you know, but if you start to work on a data set and you try to predict some aspect here, for instance, we're trying to predict whether subjects are smoking or not in the UK biobank. But let's learn that prediction on a subgroup of data of subjects, and then let's try to see if how well you do on another group of subjects. And I won't take time to describe the whole thing. You can read the paper from Jerome. But basically you're taking a really big hit in terms of accuracy of the prediction as soon as you shift the data that you've been learned on. So it's a well-known thing. What's interesting is how big is the hit, and that's very dependent on what you learn and what you're playing and so on. But basically, if you want to do something a bit like solid and generalizable, you have to do something on many different data sets. I think that's the one experiment that took a couple of years, maybe actually 3 years, was a project by Tristan Glattard, who is now at CAMH, with Madeleine Sharp and myself at the Neuro. And we took a review of the literature on Parkinson and neuroimaging, and we had a number of students and postdocs trying to replicate or reproduce papers that were in that review. So anything that was T1 images versus Parkinson either prediction or some aspect of Parkinson disease. And after a few years, quite a lot of sweat, a lot of difficulties in different directions that I won't describe. It's clear that it's super hard, especially if there's no code or there's no data. I mean, we were mostly working with the PPMI data, which is an available data set, so that data we should be able to retrieve. But even that, was hard. The cohort definition of PPMI on the papers was not, you try to run the same sort of query on the PPMI database, you don't find the same cohort, and you find different things. The image analysis pipeline, that was also super hard to reproduce. The the machine learning aspects, when we try to see whether we were doing the same kind of accuracy than other papers, that also didn't work very well. So in general, it's kind of a huge frustration to me and many colleagues that you read something in the literature and you have basically no idea whether it's reproducible or replicable. And it's not to blame the original authors. That's is a fact. That it is very hard. And one of the things that I think Roberto Toro pinned that term says you read the paper and you don't know whether it's alive or dead. So it's called a zombie paper because you don't have enough information in the paper to. Anyways. It's more not on the information aspect, but just the replicability and reproducibility problem and generalizability problem of neuroimaging. So I think we're entering a slightly different kind of a era than the kind of we lived the era of 10 years ago of data sharing was really the on the rise, and everyone wanted to there was at least some advocates, a very strong advocate of let's push the data out and so on. There are still very strong advocates of that aspect, but there's a very big data sovereignty and hopefully not data nationalism, but that could also happen. That is coming up very, very strongly for good or bad reasons, by the way. I'm not going to go into the reasons, but basically there's more and more capturing of data, at local places, and those data are almost never going to go, elsewhere. You see, for instance, how the UK Biobank just, closed the downloading aspect to get everyone on their app and so on. So solutions. So I'll describe what I think is one good and interesting direction to go, which is the the what aspect, and that's really on the about leaving the data where they are. Let's say we don't need to share, and we use some federated learning aspects to get the information, the analytic from the different data set that distributed across the world. So this is our attempt in that direction. So I'll describe that, and then I'll tell you why that's happening, how it happened. So for the data, there was we're mostly a lot working on the Parkinson aspect. So we were using PPMI, we're using ADNI for for also neurodegenerative cognitive aspects. PreventAD, Calgary dataset, the QPN dataset, all those datasets have their own governance and ethical kind of constraints. So they're not easily kind of put in one place. You can't actually reshare the derived data of many of those things and so on. We used the standard measures, so age, sex, free surfer, cortical thickness, and then subcortical volume, cognitive assessment score, and then and then some of the longitudinal aspect of that. So those are so this is Michel who took the work, and that macaron is representing that there's a lot to be done, and and she's capable of that. And this is so we're trying to predict cognitive decline with those variables in those 5 data sets, and age. So the brain age gap that you probably know about, so how close your brain is from a person of that age, with those things. So that's the distribution of the edge here and those things. So 3 setups. I mean, the key question was, how much do we lose if we can't actually share and put all the data in one place? Okay, and so the how much do we lose? So we have the silo setup with those data sets. We have the federated setup, and then the mega-analysis setup where we pretend that we can actually put everything in one place. So 3 different setups, and basically the federated setup does actually pretty well. So don't ignore a bit on the one on the right. There's still some issue with this graph, but this in general, you find that the cognitive decline or other things like the prediction of diagnosis or things actually don't take a big hit if you just try to learn in a federated manner. You have to adapt a bit like the learning aspect, and it's but there's capacity to do that in a reasonable way. And I think if we can make an infrastructure that is sufficiently low barrier for clinical researchers in the research clinical groups, we're going to get so many of those little data sets that we can't access now. It's because there's no capacity for technical capacity to share, or the problem of the governance, ethical, just the barrier of having to know, how do I share the data with the privacy aspect of the subjects, and that's a huge barrier. That's probably the barrier number 1. So what's the story? The story is that at some stage, Nikhil Bhagwat came in the lab, and he had to process a few data sets. And then he became frustrated, of course, because there's a lot of, especially one very messy data set that come from our hospital. And so created like something that is on, like we put the things in bits, but we had to organize the processing and the, where the derivative go, where the other data come from. Like, this was not only neuroimaging, there was also like a bunch of clinical data coming in and so on. So how do you organize that? So he created that project, Nipoppy, that now Michel is the kind of the main developer of, but Julia is participating a lot in, like you had heard about that yesterday, and so on. So it's decentralized data management processing kind of a system in some ways. It's also a stable pattern. I'll go very quickly on that. But the important aspect, it's hopefully creating a community of people that do about the same thing with neuroimaging data set and clinical data. And having that homogeneity and capacity of having the same sort of doing the same sort of things makes like, it's the bit direction, you would say, makes things like possible that would not be possible otherwise. So there's a lot of this bit study discussion with Jarek in particular, so we finally convinced Jarek that this is the right way to do. Anyways, it required a lot of sake, but it worked. So Nipoppy is also like more like a protocol thing. So you'll see a lot of kind of a monolithic or sort of like aspect of of software that do like neuroimaging processing, which is great, and that is absolutely necessary. But this is more like for a lab and the students that that they don't have all the technical expertise that many of you, that you have in this room. So they want to do like what's the phase number 1? What do I do? Then I check some things. Then what's the phase number 2? So it's a kind of a protocol, but also a specification and a tool to help you to use that specification. So it's more almost an aspect of training aspect and a capacity of like, okay, this is the dry lab, protocol rather than the kind of one tool aspect. So it helps you track, visualize, and all those things. It has that specification on the file system. It's very easy to do like a Nipoppy init, and you create your directories and all those things to help you adopt that specification. It has some great dashboards. So once you have done some processing, you could do like Nipoppy status and look at what's happening, and you could like look at the website, what's happening in your data. And this is the latest kind of a thing that happened. There's a bunch of pipelines that are boutiquified that makes it easy to like reuse that are now on Zenodo, and you can sort of do like a Nipoppy search of the different specific pipeline. You find a pipeline, and then you do Nipoppy install that pipeline, and then you do Nipoppy run. It has possibly all the runtime execution environments with that pipeline. So I think that's super useful, and that really has been adopted quite a bit, and I'll come back to that. But I think in a few years the adoption was quite remarkable. So I would say, we now know where are things on the disk. We now know how to launch like a container. There's a little arm to launch that with a Slurm and all those things. So the logistical aspect of a processing of a neuroimaging study can be, let's say it's done. It's not done, of course, but let's say it's kind of mostly like sorted. The second thing that happened, independently, I think I want to point out that, is that Seb came in the lab and thought, okay, we are still in kind of a basic problem with the fundability of data. So he and the team, and like we started to work on the, okay, let's not move the data, let's create little nodes of data that share the metadata, and you've seen like a lot of example of that in in this conference. So we want to move from the large centralized databases that are have a bunch of issues to like a more distributed infrastructure where the data stay local, and therefore they're based on standards. Otherwise, it's super hard to adapt everything to the local aspect. And to and make sure that you can find data and reduce the bias and cohort definition that you usually have in datasets. So Neurobagel has an aspect which is user-oriented. How do I annotate with a common data model, possibly a common data model for a community, some of the data? If there is a standard like bits, you can kind of scrap already all the metadata about that. Otherwise, you and only you know that X3 to 3 column in my Excel spreadsheet means actually that this is an assessment on like a whatever assessment you have done on that subject. So that is something that someone has to know and has to like say, okay, this is it, this is that thing. And M here in that column is actually male and F is female and so on. I remember the slide that Chris showed at some stage, like look at all the metadata in OpenNeuro, and it's wild what you can get in the TSV files because it's just like unharmonized. So that bit, and then there's really cool tools to actually create a node and a little database, and then a federated cohort discovery, and you can go on the web and look at query.neurobagel.org and search across many places in the world now for creating a cohort. And there's a couple of some of the places that have adopted that system. I think the key thing here was the first one, which is basically make it super easy for people to annotate things, and actually the third one is very key as well. The second one, which is make it really low barrier as well to actually install a node somewhere. And that was technically, I won't talk about the technical aspect of that. That was technically the thing that was invested a lot. 5 minutes, okay. Skip that. This is new query.neurobagel.org. Actually, search on the pipelines that have been, thanks to Jarek and Chris and others, that have been run on OpenNeuro. And there's an OpenNeuro sort of a way of searching. You can search OpenNeuro with Neurobagel on a harmonized dataset. The thing that has happened now is that possibly the variable, the semantic aspect is sorted. So we now know that that variable is age, that variable is sex, that one is means of male, that and so on. So we had the logistical aspect sorted. Now we have the semantic aspect kind of sorted. Like obviously, okay. The third thing that happened is that I met with a team of people that are doing something called FedBiomed. So FedBiomed has a lot of contributors. Marco here is the one of the founder of that project. And it's a project about, how do I, describe a plan for training, and how do I send that plan to nodes, and how do I retrieve aggregated data that are, or possibly encrypted things, so that there's homomorphic encryption aspect. There's a VPN that is created so that people can the nodes can talk to the researcher without, escaping information out that things. So FedBiomed is a very mature project that is doing federated learning. But FedBiomed doesn't know what the data are. It doesn't know what the variables semantic are, right? So that was the third thing that happened. So that's a federated analysis is to some extent sorted here. And then the fourth thing, which is a really important piece, is that Enigma had a use case. They also had that, many sites with different places that couldn't share data and so on. And Enigma PD was, and the lab came to the Enigma PD people a couple of times. They had workshop and so on. And so we installed nodes. We have now a leaderboard of Nipoppy organization, way of processing their data in all those sites. There's a little paper that describes how this happened. But the social aspect and the use case aspect, which is completely critical to everything that we do, was actually there and sorted. So I would say community aspects where there's a demand and there's an actual use case was there. So now everything's done. So we are going to, this is happening at the moment, is that the semantic aspect is going to be reused by FedBiomed, so that you know which variables are on the disk. The organization aspect is used by FedBiomed as well, so that you know where are the data, where to put, and so on and so on. So that's basically it. That's the story. It happened kind of independently, which is it's quite funny. So there was this ingredients like an invention of caramel. There's sugar, there's butter, and then suddenly you put that together and you cook that and you got caramel. It's and I felt a bit like that, with this project. Or the other way to think of it is that we're a bit like this typing things, and then suddenly there's a sentence that comes out on the paper, and that's anyways. So anyway, this is like, possible direction with like, without distributed management. I love the fact that, the first talk that Julia gave here last year was to say that she couldn't use data lab in her center. I'm now describing how to do without distributed data management. So we are here to disrupt, the conference, obviously, right? I want to acknowledge many people. Honestly, it's as much as a technical, as much as a social work that is being done here. But I think it's a fantastic direction, and there's already kind of a flurry of ideas of how to connect with the actual distributed data management problem, because that is going to be useful. So I want to acknowledge the various communities that we've worked with, especially the BIDS one, but others as well. And I think that's it. Thank you.